All right, let's jump right in. Today we're talking about something huge, a powerful force that has shaped literally every single thing you see on this planet, every mountain, every ocean, every single continent. Let's dive into the amazing story of our restless planet. Here's a wild thought for you. Right now, you are riding on a gigantic, moving piece of rock. No, seriously, the ground under your feet, it's not solid and stable. It's actually part of a massive plate that's constantly, slowly, drifting. You, me, all of us, we're passengers on an incredible planet-sized road trip. Okay, so let's start at the beginning. This whole story kicks off not with some big, flashy discovery, but with a simple observation. A puzzle, really. A planet-sized puzzle that for centuries, people just looked at and tried to make sense of. I mean, you've probably looked at a map and wondered this yourself, right? Why does the coastline of South America look like it could just snap right into Africa? And how is it possible that we find the exact same fossils of land animals on continents now separated by thousands of miles of ocean? Geologists even found matching rock formations on opposite sides of the Atlantic. It didn't add up. How could that even be?
The answer to this huge puzzle? Well, it wasn't on the surface at all. To find the engine powerful enough to literally shove continents around, we have to go deep. I mean, way deep inside the Earth, down to its incredibly hot, molten heart.
Yeah, the core of our planet is basically a giant furnace just cranking out an unbelievable amount of energy. And all that heat has to go somewhere, right? As it flows outward, it creates this churning, dynamic system in the layer right below the crust, the layer we call the mantle.
And this right here is the engine itself, convection currents. The easiest way to picture it is like a pot of boiling water. You know how the hot water at the bottom heats up, rises, cools off at the top, and then sinks back down again? Well, the exact same thing is happening inside the Earth, only with molten rock, and on a scale that is just mind-bogglingly huge.
And this is basically how it works. That intense heat from the core warms up rock deep in the mantle, which makes it less dense, causing it to rise. As it gets closer to the crust, it cools down, gets denser, and sinks back toward the core. This slow, powerful, circular motion acts like a giant conveyor belt for the crust floating on top of it.
So, we've got this incredible engine churning away deep inside the Earth. But how does a bunch of swirling hot rock actually move the solid ground we live on? Well, this is where the action really happens, at the edges of the plates.
You see, the Earth's crust isn't one solid piece. It's actually broken up into a number of these huge plates. And as those convection currents churn below in the mantle, they're literally dragging these plates along for the ride. And that means the plates are constantly crashing into, pulling away from, and scraping past each other. These interactions happen at the plate boundaries, and they come in three main flavors. At convergent boundaries, plates collide. At divergent boundaries, they pull apart. And at transform boundaries, they slide sideways past each other. And each one of these movements creates its own unique kind of geological drama. At convergent boundaries, you get geological fireworks. When two continental plates slam into each other, the crust crumples up, pushing up massive mountain ranges like the Himalayas. If an oceanic plate collides with a continental one, the denser ocean plate slides underneath, melts, and fuels the creation of volcanoes. Divergent boundaries are like the planet's construction zones. As the plates pull apart, magma from the mantle rises up to fill the gap. It cools, it solidifies, and it creates brand new crust and these huge underwater mountain ranges called mid-ocean ridges. This is literally where our planet is being remade. And then you have transform boundaries. Here, plates are just grinding past each other horizontally. But the rock doesn't slide smoothly. It gets stuck. The stress just builds and builds for years, decades, even centuries, until it suddenly lets go in a violent jolt. And that jolt is what causes many of the world's most powerful earthquakes. So, we have a puzzle, and we have a powerful engine. Now, let's connect the two. This theory doesn't just explain what's happening now, it brilliantly explains all those clues from the past that baffled scientists for so long. This is the big aha moment. The seemingly random distribution of fossils and rocks and the very shape of the continents suddenly makes perfect sense when you realize that the landmasses themselves have been moving all along. And the evidence is just overwhelming. The fossils match because the animals once lived on the same landmass. The rock layers align because they were formed together before the continents split. The continents fit because they were once joined. And we can literally map the creation of new seafloor, proving the plates are still spreading apart today. Case closed.
We can even trace this whole journey back through time. The rock and fossil records let us reconstruct the past, revealing that all the continents were once fused together into a single supercontinent, Pangaea. Then, over hundreds of millions of years, that fiery engine in the mantle slowly tore it apart, rearranging the pieces into the world we know today.
But this isn't just a history lesson. This incredible process is happening right now, continuously reshaping the world we live in and impacting our lives in some pretty profound ways.
Here's the bottom line. Every time you see a news report about a volcanic eruption or an earthquake, you are watching plate tectonics in action. Every mountain you see, every valley you look into, is a monument to the immense power of this ongoing geological process. From the slow, patient work of building mountains inch by inch, to the sudden, violent release of energy in an earthquake, the movement of these plates is the ultimate architect of our planet's surface. It's a force of both creation and destruction. So the key takeaway here is pretty simple. Our planet is not a static ball of rock. It is a dynamic, living system. The very ground beneath our feet is constantly alive with energy and motion. And that leaves us with a fascinating thought. The plates are still moving, about as fast as your fingernails grow. So what comes next? Will the Atlantic Ocean keep getting wider? Will a new supercontinent eventually form? The story of our planet is far from over, and we're all just along for the ride.